Hi friends, now here in this video we are going to see the terms which are used in case of chain drives. And when we say it is a chain, that chain would be having a number of hinge centers, and that hinge centers are going to be mounted on a sprocket. Sprocket is a wheel which is having number of teeth, and over that teeth the chain is wrapped or wound. And the terms which are used, I'll write it down here. The terms used in chain drives are, first is called as the pitch of the chain, and the second one is called as pitch circle diameter of chain. Now when I say that it is a pitch of a chain, it means that it will be the distance measured between the two hinge centers. For example, on a chain we have number of hinge centers. So when we measure the distance between the adjacent hinge centers, that would be called as the pitch of the chain, denoted by P, and this pitch will remain constant throughout the length of the chain. And in short, I can just say that, or I can write it down, that pitch is, then the second definition is, it is called as the pitch circle diameter of the chain. Now the chain would be wrapped around the sprocket, and when it passes over the sprocket, there are number of hinge centers. Like for example, as shown in the figure here, we have A, B, C, D, E and F. These are the hinge centers over which the chain is mounted. That is, these are the points on the sprocket over which the chain is mounted, and the circle which is generated through all these hinge centers is called as the pitch circle. So I'll write it down that it is the circle which passes through all the hinge centers of a chain, and pitch circle diameter is denoted by D. Next, as we can see in this diagram, when the chain is mounted onto the sprocket, A indicates one hinge center, B is the other hinge center, and both of them are subtending or making an angle theta at the center of the chain. So here I would be giving the relation between the pitch circle diameter and the pitch of the chain, considering this figure. So I would be drawing this triangle, which is triangle AOB, separately in order to explain the relation between the pitch of a chain and the pitch circle diameter, and that relation would be helpful to us while solving the derivation or the problems in the further part of this chapter. So let us get started. So the next heading is relation between pitch and pitch circle diameter of a chain. AOB is the triangle which I have taken from the diagram, and here the angle AOB is theta. A and B are the hinge centers. O is the center of the sprocket. Now I am drawing a perpendicular through point O on line AB. This AB indicates the pitch of the chain, denoted as P. Next, from the diagram it is clear that O to A is nothing but the radius of the pitch circle diameter. As the pitch circle diameter is D, so O to A distance would be the radius, which is D by 2. So I'll mark AO as D by 2. Next, when I have drawn this perpendicular O, I'll say this is perpendicular O to M, OM, perpendicular to AB. Now, in order to find the pitch, I'll divide this triangle into two parts. Like I'll say, here I am taking this triangle AMO, so the angle over here, which is AOM, will be exactly half. This will be theta by 2, and so the remaining angle will also be theta by 2. So taking another triangle separate, triangle AMO, angle AOM is theta by 2 and AO indicates the radius of the pitch circle. Now if I am able to get AM, then I'll simply multiply it by 2 so that I get the value of AB, and AB is nothing but the pitch of the chain. So I'll say that in triangle AMO, now I want AM. This is opposite to the theta, so I would be using the formula of sine theta, that is sine theta by 2, sine of the angle is opposite side, which is AM, divided by hypotenuse side, which is AO. So therefore AM will be equal to AO sine theta by 2, then AO is D by 2, so it is D by 2 sine theta by 2. Next, here this angle theta, it can be found out by using the relation with the number of teeth on the sprocket, and from that I can say that theta value will be equal to the total angle, which is 360 degree, divided by T, that is the number of teeth on the sprocket, where T is equal to number of teeth on sprocket So here I would be putting the value, instead of theta, I would be writing it as 360 divided by T divided by 2. So here this will become 180. So finally I will be getting the value of AM as D by 2 sine. This is 360 divided by T. Actually here T is not in the numerator, but it is in the denominator, so it is 360 by T. That will give me the value as 180 divided by T after cancellation, and this is the value of AM. Next, for AB, I'll write it down that since AB is twice of AM, so therefore AB will be equal to twice of D by 2 sine 180 by T. 2 and 2 gets cancelled, so I get, instead of AB I'll write down it as pitch. So pitch becomes D sine 180 by T, and therefore when I want to write D on one side, so this D will be, when this sine 180 by T goes onto the other side, it is P divided by sine 180 by T, and it is 1 upon sine 180 by T, so that becomes cosec. So it will be P cosec 180 by T. I'll say this is equation first, and equation 1 gives the relation between pitch and pitch circle diameter of a chain. So we can easily say that the pitch circle diameter is P into cosec 180 divided by T, where T indicates the number of teeth on the sprocket. So that was it from this video. In the further videos we are going to see some more relations and some more problems related to chain drives.